Okay, we are live. What's up, everybody? This is Ray, and welcome to our monthly Tech Talk for December 2014. This is our 17th free Tech Talk, and this month's tutorial team member Scott Gardner is giving a Tech Talk called the Great CALayer Tour. CAlayers are the secret sauce behind a lot of great UIs in iOS development. With gradient layers, shape layers, replicator layers, and more, you can create some amazing effects and animations with only a few lines of code. In this talk, Scott will give you an overview of the various CA layers available to you, how you can use them in your apps, and show off a really cool demo along the way. Here's today's schedule. First, Scott will give his tech talk, and then we'll open things up to Q&A.
Hey guys, looks like Ray's having looks like Ray's having some issues right now, so I will chime in. Basically, we're going to be doing Scott's going to be doing his tech talk. Afterwards, we're going to be doing some Q&A. So if you have any questions, just definitely write them in the sidebar or whatever the chat interface is. And if you see a question that you like, you can upvote them, and we will try to get through all of them. And of course, if we have any questions ourselves, we'll chime in and make sure you have them. So with that, Scott, why don't you take it away?
All right. Thank you, Brian. Thank you, Ray. Hope you can rejoin us. And thanks, everyone, for joining us today. Again, my name is Scott Gardner, and I'm a member of the Ray Wenderlich tutorial team. Really excited today to go over CALayer and many of its subclasses and some of the cool things you can do with them. So we've got a lot of ground to cover, and so I'm going to jump right into my keynote here. We'll fire that up here in a moment. Okay, and if someone could just let me know when you do see that initial slide there, we know we can get started.
I'm not seeing it right now, Scott. Are you sharing?
Yep. Let's see. Let me try that again. Hold on. Oh, there we go. My apologies. And okay.
That's good.
We good?
Yep, that's good.
All right, thank you. All right. So again, my name's Scott Gardner. I've been developing in iOS for about 4 years now, and I recently finished a book called Transitioning to Swift. That should be out literally any day now. And I can be reached at LinkedIn. That's just a shortcut to my LinkedIn profile. And on Twitter also at ScottEG. Oh, yeah, a throwback to Movember. So today's Tech Talk, we will go over a CALayer and its subclasses, most of them anyway. And I'll also go through a demo, just a simple demo of customizing and creating a layer on top of a view. And then we'll go through and take a look at an app that I built to demonstrate and explore a variety of the capabilities of CALayer and its subclasses called Layer Player. And we'll follow that with touring through some of that code as well. So to start things out, I'm going to talk a little bit about each of these classes as we go through this keynote. And before we really get started, I should mention that Core Animation is essentially a graphics processing and animation framework that sits below UIKit and AppKit in OS X. And it uses the GPU to draw, which means you're going to get the fastest performance possible. It also provides some API to interact with Core Graphics and OpenGL ES, and we'll see that as we go along, especially when we look at some of the code. So here we are. We see a handful, or more than a handful, of different CALayer and subclass examples, and these are all part of that app, and we'll go through each one of these individually here. I'll just mention that there are a couple other things that CALayer has for subclasses, including AV synchronized layer, which is really for synchronizing timing with players, AV players. We have capture video preview layer, which is used to basically display previewed video that's currently being captured, so real time. and then a buffering display layer, which is used to display video frames, which can be either compressed or uncompressed. Those are pretty out there as far as what the capabilities they provide. They're fairly specialized. And one other that I will mention too is CA Metal Layer, which was introduced along with Metal through being debuted with iOS 8. And we do have a great tutorial on raywinderlich.com that you can check out if you haven't for that. So I'll point to that again here later on. But wanted to mention that those are the things we won't be covering. Everything you see here, we will. All right. So CALayer. CALayer is the base layer, and it is essentially responsible for managing and animating content. Every view has a backing root layer, but you can also create layers as standalone layers, and you can add them then as sub-layers to other layers. So what's the difference? So layers are lighter, and they're more performant than views, and you can do a lot of things with them that you would think you would primarily be doing, you need to be doing with views instead. Some of the things that you can do include changing its contents and positioning, of course, background color and opacity. You can set to whether it's hidden or visible, and you can mask its contents. You can also round the corners and change the border widths and colors, and even apply, drop shadow effects. So it has a lot of versatility, and just for that basic layer class, you get a lot done just by getting familiar with how to use that. Colors are assigned as Quartz color references. So, for example, where you might say UI color dot red color, you would do the same thing and then just append that with .cg color to get the CG color ref for that use within assigning background color or border color, that kind of thing. Another cool thing about layers is that most of the changes to the properties are automatically animated. So when you make changes, you'll see that in the app. I didn't have to write any additional code. Those animations for those property changes happen for free. You can actually manipulate that and add additional animations if you want to. And you can even get a copy of the layer as it's being animated and as it appears on screen, calling a method called presentation layer. That's coinciding with something called model layer, which returns the actual layer at the final state. And there's not a lot of use cases where you would need to actually access that directly, but there might be some, and so it's good to be aware of that's out there. We will see an example, by the way, of doing a custom animation when we get to CA replicator layer a little later on in the presentation, and then certainly through the demo and through the code. So as I mentioned earlier, CALayer draws using the GPU, which is going to be much faster performance than if we were relying on using the CPU for drawing. And there actually is a property that you can set called draw asynchronously on CALayer. And it's generally recommended that you wouldn't set that if the item was not going to be drawn continuously, repeatedly, because it could actually impede performance. And we'll see later on that there's a sort of a component, or I should say a pair with that and being able to decide if you want to rasterize your layer, and that might be where something is not going to be drawn frequently, and that would be a good way to get optimized performance out of that. Another difference between layers and views are that layers are not part of the responder chain, so they do not react to touches. You can hit test them, and we'll talk about that little layer later, so that will allow you to simply be able to tell if that layer was in fact touched essentially through a tap. But you can't do anything more of that or do any gestures, and you'll have to rely on working with views in concert with layers in order to get some of those things accomplished. One other thing before I move on here, and this is just a good thing to point out, there's a property called geometry flipped, and Apple actually says in the docs don't use that. But if you don't, and we'll see in the demo app in a little while, that your geometry, because of course iOS has got inverted geometry for compared to the OS X geometry, and so you'll want to set that to true if you're going to use some of these properties for positioning layer contents. And as an example we'll see here is the star will actually go to the top or bottom depending on what the gravity is set to. All right, so moving on, and we're going to jump into CA scroll layer. Now, this is a fairly basic piece of API. It's basically designed to display a portion of scrollable content. UI scroll view doesn't even use it, though. It changes its backing layers bounds directly. So this is comparatively of lesser capability than UI scroll view, and wouldn't necessarily recommend using it for anything where you want to have touch-based scrolling, where the user's panning and gestures to to move around a scrollable amount of content on screen. But you might use it for something if you didn't want that to be something that the user had touch control over. Maybe they're selecting something that automatically scrolls to a certain point on a map or something of that nature. Smaller or moderately sized images would be okay. And then we'll see later on that you might actually opt for using CALayer if you have really large images, because that'll automatically draw asynchronously, and you can do some pretty cool things with that. So that being said, like I said, scroll views for touch-based and CALayer when scrolling larger images will probably be your best bet. But CALayer does have its place in the toolbox. It's good to be aware of for some of the lighter work that you might need to do. Okay, CA text layer. This one's kind of neat. This sort of behaves like a UI label, except for, of course, it's going to be a better performance, it being lighter weight and it being, taking advantage of the GPU to do drawing and such. It doesn't have quite as many capabilities, but it has enough that I think you can find it to be a useful alternative for getting better performance and just about as much capability as you may need when you're rendering text. And this can be plain text or attributed text. Instead of using a UI font as you would with a UI label, you would actually assign a CT font ref or a CG font ref in iOS, or an NS font in OS 10. And as you'd expect, you can change the properties like the text and the font and the size and coloring, and if it wraps or aligns, and how it handles truncation, those ellipses and where those appear if the text doesn't fit in its bounds, that kind of thing, before it gets clipped, that is. AV player layer. So this is a really basic one as well. It basically provides for housing an AV player, and that's really where the work is done. An AV player will play AV assets, one or more videos, for example, but it also can play the sound accordingly. Has a video gravity property that's similar to UI View's content mode, resize, aspect, or aspect fill, that type of thing. And you can also check to see if the AV player is ready to be displayed by calling on the ready for display property, and that'll return if it's ready to display or not. And you can get a rect, or essentially the frame of the actual player, by calling video rect. And again, some of this stuff we'll see in code as we go along. One thing I do want to mention about this, though, is that essentially setting the rate is how you play or pause the AV player asset. Play is a rate of 1.0, pause is a rate of 0, and you can also play in reverse. And so, for example, -1 would be playing at a normal speed, but in reverse. For any of these, though, they will call first to check to see if the player's item can actually play, for example, fast forward, or slow forward, or reverse. And not all assets will automatically be able to do that. In fact, the one that I used here doesn't have that capability to play in reverse, only fast forward and slow forward. And then the last thing is that you can register to, let me just get something in the way here. You can register, one second, I just lost my screen here. There we go. You can register to get AV player items did play to end notification, and that can be something you can then use to then set the seek back to the beginning of that asset, and that will essentially accomplish looping through that video asset repeatedly and continuously. And that's, if you can see it on the slide here, I have that little loop switch, and that's what it's going to do. One thing I found, though, and I sort of looked around online, and I saw that this seemed to be the case, and there were some sort of hacky type of workarounds. But without some of that extra effort, there is a slight pause as it seeks back. So whether you're going to maybe create another player and have two player objects and swap one in that's ready to play and doesn't experience the pause, that might be one way to go around that. But it's just something to be aware of. You won't get a completely seamless looping out of the box. Okay, gradient layer. So essentially, this would be used with two or more colors. You could use it for one, but then there really isn't a gradient. And essentially, the CA gradient layer has a colors property, which is an array of CG color objects. You set a start and end point, and that's going to be where the gradient starts and ends, of course, along an axial or a linear basis. That's the only type that's currently available, so that's the only way that it'll work. So essentially, it'll just gradiate from one color to the other to the next through that colors property array through the start to the end points. You can optionally also set a locations property, which is basically an array of CG points. That if you didn't want to have those gradations to be evenly distributed over that range, then you can set the locations property, and then it'll adhere to that. Of course, if you do set the locations property and you don't have the exact same number of locations as you do colors, you get a crasher because it doesn't know what to do at that point. So you want to make sure those match up. And that's it for that. CA replicator layer. I've seen so many awesome examples. This is just a really simple one here, where we have this red rectangle that gets repeated and transformed with a delay to its drawing. So that's essentially what CA replicator can do for you. We're duplicating one source layer for a specified number of copies. We can transform the position and the color of each copy, and the drawing can be delayed. You can also preserve depth using CA replicator layers, so you'd have a similar sort of 3D behavior that you get with a CA transform layer, which we'll see in a little while. This is just a 2D rendering, but you could actually do it in 3D if you wanted to and do some pretty interesting things. So this just really scratches the surface of the capabilities of CA replicator layer. Very powerful. Tile layer. So there's a couple different use cases for tile layer that I've found. One is, as we see on this screenshot here of the app, we're just looking at a single layer that's being drawn repeatedly, and then over that I've actually used some CG paths to draw out what that actually is a star. I can't tell because we're zoomed in at 50 times zoom, I believe that is. Yeah. But essentially with CA tile layer, you can repeatedly draw a single tile, or you can slice up a really large image into slices and then render those tiles, and that happens asynchronously. Even if you have one tile, it's going to automatically render that asynchronously. So that's really a powerful way to get fast display of a lot of or large content with relatively little effort. The amount of code that you write to do this is pretty thin. I will also mention too that in the Layer Player project, which that code will be part of a tutorial that I am working on right now and should be wrapped up on here soon, and I'll include a little helper class called Tile Cutter. And I actually adapted that from another Ray Wenderlich tutorial team member, Nick Lockwood, who wrote an excellent book on iOS core animation advanced techniques. And in that, he shared some code that it was a tile cutter type code that would take a large image and chop it up. I built that into the project as essentially a category, and that's available if you want to grab your own image and slice it up. It'll automatically do that and display it, so kind of cool. Another thing I'll mention too, and we'll see this when we start to play around with the app, and sometimes seeing it, and that's the whole purpose of the app, is just visually seeing how the changes that you're making affect the actual visual layer. But fade, in this case, the property fade on a CA tile layer is the fade in delay. So as you're scrolling around, you'll see as we set that fade out that the fades will take longer and it'll have more of a ghostly effect as we go through it. And then also, this last one here, we see right above the zoom scale, detail bias. That's actually levels of detail bias. And we're zoomed in at 50 times. And when we get into the app, we'll see this. If I had that levels of detail bias set to 0, for example, then those white lines would be really blurry, of course. They'd be very pixelated, and they'd be really quite ugly. But just setting that detail bias, this, of course, cost performance, but we can get the performance that we're looking for because we're writing or drawing through the GPU, and this gets really crisp. This is 50 times zoom on this star path that got drawn, and that's pretty cool that you can do that with just a little bit of code. Okay, CA shape layer. So here we're using vectors, right? So we're going to be, rather than having images that don't really scale and they get pixelated, and you of course have to have 1x, 2x, and now 3x, and who wants that? So this is really an alternative to that. You can change line thickness, dashing. You can change how lines join, whether they're squared or rounded, and these types of things. And of course, colors and fill colors and all that. So writing these paths can be somewhat tedious, right? And so there is a great tool out there for that. It's called PaintCode. I love it. You can use that to draw paths. I use that to draw this particular star, and also I talked to them, and I said, I'm doing this tech talk today, and I'd like to mention PaintCode. I love it as a developer tool. And he responded back and gave us a coupon for $20 off. So if you don't have PaintCode, definitely check it out. And if you decide you want to buy it, there's $20 in your pocket. CALayer. Probably the coolest name of them all. Maybe CAMetalLayer is right above it. I don't know. It depends. But as cool as it sounds, it's not all that fun to use, in my opinion. You're really getting very close to the bare metal with this, and you're basically using a CALayer object to write OpenGL. And you know, as much as anybody would want to be doing that on a regular basis, this would be the tool to use for it. Apple has advice or suggestions here for optimal use of the CALayer, including that you want to make the layer opaque and make sure it matches the display bounds, and don't transform it, and don't draw additional layers on top of it. Or if you do, then first place a transparent 2D context on top of it. And so all these limitations and requirements to get the performance out of it that you'd hope would lead me to believe that your best bet is probably going to be to use GLK or a CAMetalLayer instead. And like I said, we have a tutorial, iOS 8 Metal tutorial with Swift getting started, and there's a part 2 to that as well. You go through that, you'll know everything there is to know about using CAMetalLayer. All right, drawing 3D structures. This one was a fun one, and I actually used a helper class from Bill Dudney called Trackball, which took care of the actual animation and the transforms to be applied to this cube. But essentially, CA transform layer allows us to draw in 3D. It doesn't flatten the hierarchy like the other layers. Each sublayer has its own opacity. So as we see here, the red one and the purple one I've set to toggle alphas, and now we can see the partially have partial opacity there. And we can apply transforms, but the transforms actually get applied to the sublayers, and it ignores any of the rendered layer properties. So if you were trying to use this with changing the width or color or that kind of thing, that won't actually work. And again, I mentioned earlier that you can't directly hit test, or I didn't mention this, you can't directly hit test CA transform layer itself because it doesn't have a 2D coordinate space that would need to have those touches mapped to it, but you can hit test each of its individual sublayers, and that's what we do in this app. When you tap or move around on this particular cube, every time you tap on it or move it, you'll see a little box tapped label on top, and that's what's happening. I'm using a hit test on the layers. And a couple ways you can do that would be by overriding hit test or returning self, or using contains point on the background layers and returning false. That's essentially giving us the same effect as responding to the specific layer being touched, and not having it pass all the way through and trigger other things that you don't want to. Sorry to cover that about hit testing the sublayers. All right, last one here, and then we're going to jump into a demo, is CAMetalLayer. And there is just so much to this one. It's a lot of fun to play around with. You can render and animate emitter cells. And these are, like, for example, these stars, and just rendering and emitting those. And they actually render above the background, of course, and border. And even as we get into the app, we'll see when you leave a particular view, they sort of have this trailing remnant of display on screen because they're above all other layers on that. So it's pretty interesting to use. And there's just a boatload of properties that you can change of both the emitter itself and the emitter cell. Things like position, of course, and shape and size and spinning and the velocity and how quickly new particles are spawned and the lifetime of each particle. You can also preserve depth and have a 3D type particle emitter here if you want to get really fancy with this. It's capable of handling that. And emitter cells also can be changed extensively, and you can see on the slide there it's 4 lines of text. I won't read through all of it, but definitely check it out. And this app and this particular scene in the app should help you get some familiarity with how changing some of these properties will have an effect on the actual emitter itself. So, okay, I'm going to jump into some demos now. First things first, and create a simple project. Let's call this layer test. Maybe I should call it layer test 2. Hold on. Here we go. Layer test 2. Perfect. Okay, so what we're going to do here is we're going to just go in, we're going to have a view that we're going to use as sort of a host for the layer, and then we're going to add a layer to it, and then we're going to play around with changing some of that layer's properties and see how that affects the display of the view. And I'll just go full screen on this here. Let's see. Okay, so go to the storyboard, and I will drag out a view. And I'm going to set this view to the 150 by 150. And then I'll just set some constraints on it to keep it where we want it. And that should be good to go. Okay, next I'm going to just grab a handle to this, so I'll create an outlet. And we'll just call this text view. Real original. All right. Certainly is a treat looking at this code at this size. Okay. So I'm also going to just create a computed property here just to make my life a little easier in terms of typing. So we're just going to call it L. That's going to be of type CALayer. Position there. And we will return the test view.layer. Okay. Next, I'm going to just get rid of some of these extra comments that we don't need to look at, and we don't have to worry about memory right now. Next, I'm going to just create a separate function, separate method called setUpLayer. And in it, we're going to set that background color. I'm not getting code completion. UI color, blue color. And remember, we need to grab the CG color. CG color. All right. And we'll stop right there, and we'll just go ahead and run and see what this looks like. Actually, let's see. What are we doing here? Background color equals UI color, blue color.
Do you need to import Quartz Core?
No, you don't. I just have to spell background correctly. There we go. And I will also need to now call this in my view.load setUpLayer. Now I'm getting background, or now I'm getting a code completion again, so that's wonderful. All right, let's give that a whirl, and we should see a big blue square. There we go. All right, so I've got, let's see, I've got a star that I am going to pull into this project, and I'll just put it in my image assets here. And of course, we probably want to have, the different versions. If we're going to pull in a ping or something like that, we want to have a 2x and 3x. But for sake of example here, we'll just move right along with it. And so I will actually set the layer's contents to a UI image named star. And I have to get the CG instance of that. There we go. So let's go ahead and build that, make sure we look good here, and run it. We should see a star in the middle of that square. Now we see what's happening is it's getting resize aspect fit, which means it's distorting and skewing, and of course because this star is not that big of an image, it doesn't look so good. So we'll see how that can be improved upon by using CG, by using other CALayer subclasses to draw. But we can also, there's a few properties on CALayer that we can apply that can help with when there's a magnification filter is being used to slightly improve and slightly reduce the aliasing that you see there. But let's go ahead and set the contents gravity, which is by default to that aspect resize. We're going to set that to contents gravity equals K CA. Oh, lovely. Has anyone seen that before? CA gravity center. And let's give that a whirl. Yep. Okay, and I will just, I'm noticing that I'm trying to keep on time here, so I'm actually going to copy and paste some code in here just so we can move right along. You're not watching me battle with the on-again, off-again source kit and code completion issues. So let's just do that. And what I'm going to do here, I'll paste it in and then we'll talk through it. So I'm setting geometry flip to true. And actually, I'll leave that off for 1 second, and you'll see. Well, when we get to the app, I'll do this. We'll see that if we didn't set that, then if we set the contents gravity to KCA gravity top, it would actually display at the bottom of the frame of the layer because it's inverted. So I'm creating a border width of 100, and I'm just setting the border color to red color, much like we set the background color. We get a UI color and get the CG color instance of that. And then we set some opacity. Opacity is 0 by default, and the radius, which is we're setting to 10. And so when I run this code, we now have this big red bordered square. Now, what I'll do now is I'll quickly add a couple of gesture recognizers. Where are they? Here we go. So we'll add a tap and a pinch. And I'll just put those right on the view themselves. I'm going to paste in some code here, and I'll talk through it briefly. Okay, so what we're looking at here, and I'll match these up in here in a moment, is we're looking at this tap gesture recognizer, which is going to just change the opacity. It's going to toggle it between 0.7 and 0 when you tap. And on a pinch gesture recognizer, we're going to see if we're pinching in or out by checking the scale. And we'll set an offset, and then we'll adjust the frame and the round, the border radius and the border width will set by that offset. And so if I go ahead and pair those up here, let's see, this might, let's see, this is the, oh, 1 second, that's the pinch, okay, that. Hold on. No, that worked. And that worked. And let's hope the live demo gods are with us here. There we go. And there we go. So I'm tapping and I am toggling the shadow on and off. And if I just go ahead and do a pinch gesture here, we've got ourselves a pretty cool little avatar maker. You just put your own face in there and adjust that size, the frame, the way you like it, and Bob's your uncle. All right, so that's just a sort of a brief example of basically creating a CA layer and customizing it by adjusting some of those properties. And what I'll do now is I'll close this out, and I'm going to go right into the layer player and spend about maybe 5 minutes going through this. Then we'll take a look at some of the code, and then we should have some time for some Q&A. So this is the app that we've been talking about, CALayer. And we see contents gravity. Contents, if I go to top, you know, it's at the bottom. But if I flip it, then of course it goes to the top. Now notice that not all of these are animatable by default, and so that setting that contents gravity doesn't automatically animate it. If you wanted to have a smooth animation, you'd have to handle that yourself. But there's quite a few different different properties here that you can change. These are most of them, but not all of them. So I definitely recommend consulting the documentation on that. Here I'm adjusting the shadow and the radius and give a little more of a blur effect and that kind of thing. And if I did have an image that would potentially be large, or I don't know the size of it at runtime, I might want to at least try using the trilinear magnification filter. It has a moderate improvement. Chances are that you'll be better off trying to, using a layer drawing instead in this case, or using CG path drawing or something like that. Scroll layer, like I said, there's not a whole lot to it. Here I'm just actually panning, and I'm using a pan gesture recognizer on the view itself and then instructing to set the bounds. and I can lock them. So if I wanted to, I could lock it horizontally or vertically. Not a lot there. CA text layer. So we're just looking at Helvetica, but I can just tap on this, and all these changes will be animated, and I can zoom in and out on the text. That can be kind of cool. I can turn wrapping on or off. I can set truncation. So in this case, if I zoom in on this, we see that we're getting the ellipsis in the middle, but I can also set it to the end or start, and I can also align and justify, and that can have neat effect if you're working at a newspaper, for example. Player layer is, again, just essentially a house for a player, an AV player object that plays AV player item assets. And I've got this set to loop right now, so I can just do this here, and that's going to automatically play. And I can play normal and half speed. Turn that volume down a little bit. That's about all there is to it, but it can be a very lightweight way to put up a player on screen if you want to play back some AV content. Gradient layer. So here we see we have Roy G. Biv. We have all the different colors represented here, and I've just got them stagger stepped through, and I can move my start to 0, 0 and my end to 1, 1, and essentially you see that linear gradient path happens from the top left to the bottom right, and I can just go in here and turn off some of the colors or adjust some of the colorations out to get different effects. And again, playing around with this is really where you start to say, oh, I know I could use this. I could create a pretty cool background instead of having several different image assets that are relatively large in size to do backgrounds. I might be able to get away with doing something using gradients and maybe a couple of overlay images just to add a little bit of taste to it. So that's where gradient layers can really come in handy. This looks like that spinner that you might get when you're waiting for something. Well, essentially you can do things like that, but lots of other things. And here we're just adjusting the layer size from its starting point. We can change the count if we don't want that to actually animate all the way around. Essentially what it's doing is it's delaying the drawing of each of these transformed and rotated instances of this particular rectangular layer. And I can also change that delay to be longer and change the color, and I'm just using some switches for that just to make things easy. So CA tile layer has a couple of different uses here, as I mentioned in the keynote part of things. Right now we're just looking at tiles of 100 points size, and this is also set to the screen scale, so we get anti-aliasing out of that. But if I zoom in on this, and then now go over that line, we see it looks terrible. But if I increase that detail bias, that has a factor. Every time you do that, has a factor of 2, increasing that. So now you see we actually have a pretty crisp line, even at 50 times zoom. And if I adjust this fade duration, we see as I adjust that out, it takes longer for each of those tiles to fade in, which has an interesting animation effect if that's something you're going for. I'm going to set that to 0. I'm going to flip over or pull up this. This is a 5200 by 3200 sized, pixel-sized image, and like I said, there's code in the app that automatically chopped this up into tiles, properly sized tiles, and handled the extras and all that. And thanks to Nick Lockwood for that. And this essentially displays this whole thing asynchronously, tile by tile, and it calls them up there just in time. You might see a little bit of flickering, but for the size image that it is, you're getting tremendously better performance than if you tried to just do this. In fact, you probably wouldn't even be able to. It might crash the app as large as this image is. All right, a couple more here. CA shape layer. This is where we're actually using CG path drawing to create this, and I used a paint code for that. It's a great app for that. I can, just change some of the properties on this and see how they are animated automatically. For example, the fill and these types of things. So fun to play around with that and get a feel for it. And looking at the code, you'll be able to, really map what each of these controls and the properties do, and how they are, how they can be, changed in different ways to create interesting effects. Not a lot here for CALayer. I didn't have any really opportunity to put any control dials on it, because you really are, as you look at the code, you're essentially writing OpenGL and hand cranking that code to basically draw a triangle. So we have 2 triangles of each color to give the illusion of a cube. Quite a bit of code went into that. And again, I'd probably use GLK views or CA metal layers for doing any of that kind of work rather than dealing with CA evil layers. But hey, CA transform layer is using the trackball code that I got from Bill Dudney, but everything else, and that code's in the project. But this particular, CA transform layer is a collection or a sub-layers array of all these different layers, and I've just added a CA text layer, swipe me on top of that particular layer, and of course we can set the opacity and have fun with that and get a feel for what that's like. And the last one here, and then we'll go ahead and dive into some code again. We're looking at CA emitter layer, and I have this set right now with the x acceleration at -750, which is what gives it the appearance that it's trailing behind. This thing is in motion, and the particles are emitting to the rear as it moves along. And of course, if I change that, or I just move this thing around, change some of these velocity settings, you can do some really interesting things. And this is really, this sort of broaches into even sort of game development and those types of things, just because of the capabilities of particle layers. But you might find something interesting to do with them, and there's quite a few properties that you can change here to create a variety of effects. So have fun with that. Okay, I am going to go ahead and jump out of the simulator and into the actual code that created that app. We'll do this. I'm going to probably just go through this fairly quickly here, so we have some time to have some questions and open discussion about things. So let's just actually first and foremost look at the storyboard. I like to always start there and get a feel for what the app looks like. So what we see here is we just have a simple table view, and then each one of these CA layers is a separate scene. Some of them actually have two scenes, as we see for the layer here, because we have a contained table view, because there's so many controls I couldn't really fit them on screen. And we'll go through a few of these here. Let's just do, for example, take a look at the CA layer one first. And this pattern, as you go into this code, and when I make this code available online, it's actually on my GitHub, but will also be part of the tutorial that I'm writing. I follow the same pattern pretty consistently throughout the entire project. So I have a setup layer method that I'll call from viewDidLoad, and that will set my starting point properties for the layer. And then we'll react to each of the. In this case, we have an embed segue because I'm part of that table view there. Let me get to that particular class. Oh, it's manual. Hello. There we go. So here we have handles to all the different controls, and like I said, I use enums pretty liberally just so that we have contextually familiar, instead of just using integers or strings that might come along, whatever we're pivoting on actual enum values that just makes it a little more readable, makes the code self-documenting. So I set some of that up here, and then we react to user actions. When they flip switches and drag sliders, we're essentially updating the layer, and all of those properties that are animatable are happening for free. I didn't have to write any code for that. That's one of the great things of CALayer and just core animation in general, some of that animation that happens out of the box. Let's see, so scroll layer, let's actually close this. I'm not going to use that. We'll skip over scroll layer. We'll take a look at CA text layer. And here I basically stand up a couple of fonts when I called, sorry, that's the enum for that. But I will create a couple of fonts here and set up my text layer just with some random text, just some lorem ipsum. And each of these controls, once again, is essentially going through and updating the CA text layer's properties, and those properties, and the result of those changes are being animated. So let me just look at my notes real quick and make sure there's something I wanted to cover in any great detail. Because this code will be available for you to pull it down and play around with, and please feel free to use any of this code in your personal or professional projects. It's MIT licensed, do what you want with it. Hopefully you have fun and it helps you out.
Scott, sorry to interrupt. I just wanted to give you a 15-minute warning.
Thank you. Yep. I'm gonna basically just look at one area, and then we're gonna wrap this up and open it up for Q&A. So let's just look at, where are we at here? Here we gradient layer. So this is that one where we have those sliders that were offset. We could just set the gradient stops and what have you. And this is just one more example of where we're setting up both some color objects I have a little helper here for that just because you got to get the CG color for each one of those. And then we set up our gradient layer with some of the starting property values, and then we will actually then just respond to each of those user changes on those slides and switches and update the labels and update the properties of the CA gradient layer accordingly. So pretty straightforward code. And again, so this right here is what is it, 145 or so lines of code to get a fairly sophisticated multicolored gradient layer. And of course, this can all be compartmentalized in an object-oriented way, and then used in the project where you might not need all those colors, but you have those at your option if you need to. So a lot of functionality under the hood with CALayers, and this project hopefully helps you to just take a look at some of that code and get familiar with it, play around with the app, and go from there. All right, let's see. I'll close this out. If I do this right here, I'm going to stop screen sharing. That work? Anyone?
Yep, looks good.
Okay.
Yep, you're back.
We might have lost Ray again. He's sitting very still otherwise. Okay, so we've got a good 15 minutes here for any questions, comments, suggestions, anything like that.
I think we did lose Ray. You're right. Well, we have a couple of questions in the Q&A that I can see. I can't highlight the questions, but we have one from tutorial team member Eric Cerny, and he wants to know, would it be more performant to use layers to display information in a table view cell rather than things like UI labels and UI image views?
That's a great question. I think it's going to depend. I mean, because layers are rendering on the GPU just out of the box, they're faster performance. But I mentioned it earlier, there's basically two properties of CALayers, dry synchronously and should rasterize, that would be used for if you are drawing something repeatedly over and over again, or if you're drawing something once, you might set those properties accordingly. But as far as whether you would use view objects or layers, it depends on the complexity of it, and if layers have an out-of-the-box capability of meeting what your needs are, I'd use layers because they're going to draw on the GPU and therefore be higher performance. That's my take on it.
Okay, great. We have another question from a viewer here. He wants to know, Caesar, I don't know how to pronounce his name, but he wants to know, is there any real performance gain to be had if you use a CA layer versus a UI view if you don't need the gesture-based capabilities? I think when you were demonstrating the gesture recognizers earlier, maybe that's where that came up.
Right. So I mean, that's one of the big differences between layers and views, is that views have that extra logic to be a part of and respond to, to be part of the responder chain and respond to touches. So in a simple use case, probably not. But there's actually, if you Google it, you'll find that this talented developer went out there and did some fairly hefty benchmark testing of UI views versus CA layers, and the results are staggering when you get into high volume usage. But for just minor things, no, it's probably more a matter of programmer taste and familiarity whether you use views or layers. But because they're lighter weight, and because they use the GPU, and because they don't deal with the responder chain and some of the logic that's required of that, they are going to be, on balance, better performance. So.
Okay. We had another one come up earlier, one that I had, but another tutorial team member, Brian Broom, was asking about things about comparison with core graphics, and he was asking, when making a custom control, you can usually choose between core graphics, doing things directly with DrawRect, and to try to compose versus trying to compose your control with CALayers. So what do you think are the pros and cons versus using core graphics to draw these things versus using layers?
Well, if you like running a lot of code, then use core graphics. No. Well, core graphics is C-based procedural, API, and of course the drawing is happening on the CPU. So depending on what you're doing, you might take a little bit of performance hit. Again, CALayers are using the GPU, and if you are familiar and comfortable with using layers to stand up custom control, then CALayers would be the way that I would go on that. But again, it's going to depend, and you might as well vary, and a lot of times it's programmer happiness, how can you get the job done, and then you test and check for performance if there's any bottlenecks or any issues, and you know, don't premature optimize, but see if what you're doing works, and if it doesn't, then you might explore, you know, going in and using CALayers and figuring out how you do something very similarly using CALayers instead. I personally, I mean, like I said, you know, CG is C-based and procedural, and I prefer to use an object-oriented API. And of course, core animation and CALayers give me that that type of interface to do that. So.
You're like C. I can't kick you out, unfortunately, because Ray is hosting. But all right, we'll let that go. Ray himself had a question from earlier, and he wanted to know, out of all of the layers, because you showed us a very wide range in that great sample projects. Out of all the layers, which ones do you think are the commonly used ones, or should be commonly used, practical on sort of a day-to-day basis for most developers?
Definitely CA Eagle Layer. That should be used in every app all the time. No, that's the last one. So just regular CALayer, you can do an awful lot with that. I mean, just in terms of adding, like everything's rounded. You know, if you have pictures in an app for, you know, profile, avatar, that's generally now the UI best practice for that to be rounded. A simple CALayer with masking will get the job done on that, and set the corner radius to half the width, and you're done. So that's really a very useful, you know, particular piece of API. Gradient layers, as I mentioned too, can be a great way to get really you know, attractive-looking backgrounds for your apps without having to have a bunch of static images at 1, 2, 3x for every size device that Apple is coming out with. So gradient layers would be another favorite of mine for that type of thing. And I'm actually getting ready to use that at I'm working at a streaming media startup, and we're getting ready to do backgrounds. And just yesterday, the designer wanted to know how many different versions of the background assets would I need. I said I could do that whole thing in layers, and I'd only need that bottom portion as an asset, and he couldn't believe it. So, I mean, that's going to save a lot of effort on his part, and certainly not have to have all those assets to maintain in the project and bloating up the binary. So.
Okay, cool. We have another question from tutorial team member Eric Kerber, and he was asking, CALayer has a property called should rasterize.
Oh,
he wants to know, what does it do, and why should you use it, or I guess not use it?
Should rasterize is going to determine whether or not the layer should be rendered as a bitmap before it's basically composited to its destination, right? Before it's actually displayed, and so it would be used in a performance way on something that's only going to be drawn once, or not a lot of times, right? That's where you'll get a performance gain from setting should rasterize to true. And the opposing property to that is draws asynchronously, which if something's going to be drawn a lot, you can set draws asynchronously to true, and that will then tell it to do all the drawing on a background thread, and you'll get that performance. Of course, if you aren't drawing something frequently and you set draws asynchronously to true, you'll actually have you know, hinder performance. So it's a balancing act, and it's a lot of times you just have to think about what the actual implementation of the layers that you're using, and decide whether you're going to should rasterize or should draws asynchronously on that.
All right, we've got another question here about shapes. When you talked about CA shape layer, and our Marin was asking, who I think is back, but he wanted to know, writing the code to make neat shapes with shape layer can sometimes be tedious. And do you have any tips or any easier way to handle drawing shapes with the CA shape layer?
I do. Use paint code. I wanted to pull that up, actually. Let me pull that up really quickly here. Oh shoot! You know what? I'll include the file with the show notes, and if anybody wants to download paint code, they can open it up. I just basically took a vector of the Ray Wenderlich logo and popped that into paint code, and automatically generated all that path drawing code. You know, Bezier curve, move to point, all that boilerplate code. It creates for you, and you're using sort of Photoshop-like tools. So that's my recommendation. I don't know that I've ever actually sat down and tried to hand crank, you know, a path, but especially ever since paint code came out. So.
I'm going to jump in here because we have actually a special bonus that we're doing today. Myron Todorov has actually been looking into something that you can do with matrices on CALayers and other things as well, called the magic of M34. And I'll just turn it over to Marin so he can explain it. I think this goes in nicely with the talk here.
Cool.
Thank you, guys. I'm back. I'm sorry that I missed some of the talk. Had like technical problems, but I've prepared a couple of slides because often I see Often I see questions on the internet, what is M34 and what does it do? And a lot of people say that it's alien magic from space, and that's the whole explanation you're going to get. But actually, there's a much easier explanation. When you want to create a 3D-like effects for your layers, you can apply a 3D transform to layers on screen. And you know, probably some of you know.
Hey, Myron, did you mean to be screen sharing right now?
Yes, I'm sorry. Is it not working? I'm gonna just do it quite quickly. Okay, like so. You see that?
Yeah, it's back. Thank you.
Okay, sorry. So, God damn it. Okay. There's a little. I'm sorry. There's a little button down the screen where you press it and everything goes bonkers. Okay. Sorry. Okay, there it is. Okay, so you can rotate and scale and translate your layers by using the handy core animation functions like CA transform, 3D make rotation, make scale, and so forth. But those functions don't really give you access to modify the magical M34 member of the matrix. And this is the one that actually sets the perspective on your layers. So it's really easy to actually set perspective. You have to manually adjust the M34 member of the matrix, and that's really easy. You just create a new CA transform 3D instance by getting a copy of the identity matrix, and then you set the M34 to -1 over the camera distance. So this is the distance between the camera or the point of view of the user to the screen. And I'm going to skip the math because we don't have the time for, and I'm just going to show you some examples so you understand what values to use in here. So -1 over the distance. For example, if you use a distance of 0.1 until about 500, that works for the current generation devices, screen resolutions. So this is very close distance to the camera. It gives you a very stretched, a very distorted, very strong perspective. It would be like if this image on the left is the house, if you put your head right next to the wall, your whole viewport will be basically taken by the house's wall, and it will be so distorted, it's too close. And if you give a try to values in between, let's say 500 till 2000, that's a relatively close distance to the camera. So you get, usually for UI elements, for your applications, you get a nice perspective. So things look nice. And so if you try greater values, like over 2000, for example, for this screenshot, I used 2500, then the object is very, very far. Imagine that the house that you're seeing on a screen is very, very far, maybe close to the horizon. Then you will still see it a little bit stretched because you still will look at it at angle, but you won't really notice the perspective because it's so far. So the lines will run almost parallel. And so how to decide what to do with M34? Well, give it a try. Give some values a try and see what works for the effect that you wanna create. A good starting point is to start with a distance between 500 and maybe 2000. That works for most. But give it a try yourself. Have a look at the code after the presentation. And actually, RayWendlandt.com editor Rich Durden has prepared a very cool GitHub repository where you can play around with transformations in 3D and build nice effects. So probably we'll post a link to it as well. And that's it. I hope I didn't really delay everybody too much. Thanks.
Thank you very much. And this is actually all the time we have today. So I want to thank so much for Scott for putting together that awesome presentation, and for Maren as well for the awesome last-minute bonus presentation that he added in as well. It's a lot of great information, and I recommend that all of you download Scott's sample, which we'll put a link to on the show notes, and to his GitHub repository, and also he's releasing that to the App Store soon. So it's a really great way to just kind of play around with all the different layers, and so you can understand what you can set in terms of properties with them, and then you can look at Scott's code to see handy reference. So it's a very quick way to get started. So remember that, so actually, let me just say thanks again one last time to Scott and Maren.
Thank you very much, Ray, and thanks everyone for joining and the great questions.
Thank you.
Okay, remember that we have these Tech Talks every month. We'll be announcing January's Tech Talks soon. I'll be putting the sign-up form on the sidebar of the site. Just look for that in a few days. So that's it. Thanks for watching. I hope everybody enjoyed this Tech Talk, and we'll see you next time.